Now we'll continue another important topic. This is the relation between roots and coefficient, and it is one of the most important topic in the theory of equation, where you can find out the relation between roots and coefficient of a polynomial equation of degree n. So first we will discuss some theoretical part, and then we will continue the problems related to relation between roots and coefficient. So here the first recall related to relation between roots and coefficient. Roots and coefficients of a polynomial equation. So here let f(x) equals to a0 x to the power n plus a1 x to the power n minus 1 plus dot 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 a n minus 1 x plus n equals to 0 be a polynomial equation of degree n, where a0 is basically non-zero and all a0, a1, a2, n minus 1, n all are either real or complex number. Now let me consider, since the degree of the polynomial is n, so it has n roots and no more. The roots may be either real or complex. So let alpha 1, alpha 2, alpha n be the roots of the equation, be the roots of the equation, polynomial equation f(x) equals to 0. Then the question is, then what we can write? Then we can write a0 x to the power n plus a1 x to the power n minus 1 plus a n minus 1x plus n. This is equals to x minus alpha 1, a0 into x minus alpha 1, x minus alpha 2, x minus alpha n. And that right side will be a0 x to the power n minus summation alpha 1 x to the power n minus 2 plus dot 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 summation alpha 1 alpha 2 x to the power n minus 2 plus minus 1 whole to the power n alpha 1 alpha 2 alpha n. So here what is the meaning of summation alpha 1? Summation alpha 1 means alpha 1 plus alpha 2 plus alpha n, sum of all roots. Summation alpha 1 alpha 2, that means alpha 1 alpha 2 alpha 1 alpha 3 plus alpha 1 alpha n plus alpha 2 alpha 3 plus dot dot alpha 2 alpha n, and so on. The last is alpha n minus 1 alpha n. This is exactly meaning of summation alpha 1 alpha 2. So in that way, we just think about alpha 1 alpha 2 alpha 3, the summation, and last one is alpha 1 alpha 2 alpha n. So now we just comparing on the both side, what we will get. So from the above equality of the polynomials, from the above equality, if we compare on the both side the like power x, what we will get? We will get a1 equals to A0 minus summation alpha 1, A2 equals to A0 summation alpha 1 alpha 2, A3 equals to A0 minus summation alpha 1 alpha 2 alpha 3, and so on. The last element will be n equals to A0 minus 1 whole to the power n alpha 1 alpha 2 alpha n. And from this you can write a simple calculation. So what is the value of summation alpha 1? This will be minus A1 by A0. What is the value of summation alpha 1 alpha 2? That will be A2 by A0. And summation alpha 1 alpha 2 alpha 3, that will be minus A3 by A0 dot dot alpha 1 alpha 2 alpha n, that product is basically minus 1 whole to the power n by A0. Okay, so we just trying to give a note here. Note, so summation alpha 1 alpha 2 alpha j, that product summation will be minus 1 whole to the power j aj by a0 for all j equals to 1 to up to n. Okay, that you just recall, and you will recall the formula in the similar fashion. Now we'll come to a very basic result, and we try to find out the relation between roots and coefficient. First we'll take the polynomial of degree 2, then we'll take the polynomial equation of degree 3, and after that we'll take the polynomial equation of degree 4. So here next recall, we find out the relation between roots and coefficient for a polynomial of degree 2. We'll take the polynomial equation of degree 2. This is basically ax square plus bx plus c equals to 0. Now we are considering, let alpha beta be the roots. In position alpha and alpha 2, let alpha comma beta be the roots of the equation of 1. So then what is the relation between roots and coefficient? So then alpha plus beta, that will be minus b by a, and alpha beta equals to c by a. So if you have asked one important note, let alpha beta be a roots of the polynomial equation of an equation of degree 2 of a polynomial of degree 2. That information you have given. So then the corresponding polynomial equation is given by, so what should be the corresponding polynomial? The corresponding polynomial will be x square minus alpha plus beta into x plus alpha beta, this is equals to 0. So that will be the corresponding polynomial. So when you have given a polynomial of degree 2, you can find out the root. From this you will find out what is your alpha and what is beta. Again, if you have given two roots of a polynomial of degree 2, and from that you can find out the polynomial equation exactly that way. So now we come to the recall 3, the polynomial equation of degree 3. Recall 3 is basically polynomial equation of degree 3. So it looks like ax cube plus bx square plus cx plus d equals to 0, where a is non-zero and a, b, c, d that are basically say real or complex. So now from the equation of degree 3, so let alpha, beta, gamma be the roots, because we know from the fundamental theorem the polynomial equation of degree n must have n root, either real or complex. So let alpha, beta, gamma be the roots of the equation, the above equation. Here the equation is this: x cube plus bx square plus cx plus d. Then what should be the relation between roots and coefficient? Then relation between roots and coefficient is alpha plus beta plus gamma, that will be minus b by a, and alpha beta plus alpha gamma plus beta gamma, that will be c by a, and alpha beta gamma, this will be minus d by a. So that you can write in that way: summation alpha, this is equals to minus b by a. Summation alpha, because it is a symmetric function, so summation alpha means alpha plus beta plus gamma, and summation alpha beta, this will be c by a, and alpha beta gamma equals to minus d by a. So now we come to the next important problem, or recall. This is recall 4, polynomial equation of degree 4. So it looks like polynomial of equation of degree 4. So it will be ax square, x cube, x to the power 4 plus bx square plus cx, bx cube, cx square plus dx plus e equals to 0, where a is non-zero and all are basically coefficient, either real or complex. So here it is our polynomial equation of degree 4. It has a 4 roots. Let alpha, beta, gamma, delta be the roots of the above equation. Now the question is, what should be the relation between roots and coefficient? So then alpha plus beta plus gamma plus delta, that will be minus b by a, alpha beta, alpha gamma, alpha delta, beta gamma, beta delta, gamma delta, that will be c by a, alpha beta gamma, alpha beta delta, alpha gamma delta, beta gamma delta, that will be minus d by a, alpha beta gamma delta, that will be e by a. So here I just considering this is equation 1, 2, 3 and 4. So that we also can be written as in that form: summation alpha, this is equals to minus b by a, summation alpha beta, this is equals to c by a, summation alpha beta gamma, this is equals to minus d by a, and alpha beta gamma delta is only one term, so you can't apply any summation here, so this is e by a. In short, we can write it in that way. But the above relation, the relation to can be written as, so here this relation 2 and relation 3 we can write in different way. So here under recall 4, the first note 1, here the relation 2 can be written as, alpha plus beta into gamma plus delta plus alpha beta, here alpha beta is sum, here product, plus gamma delta, that is basically C by A. Just you see here this relation, from that we can write this one, or you can write it alpha plus gamma. So alpha plus gamma, here we just take the product and the remaining 2 is beta plus delta. So we'll write beta delta, that is also C by A. Or you can write for taking the advantage in calculation, alpha plus delta. So obviously we'll write alpha delta here, the remaining beta plus gamma. So this is also C by A. Okay, so now we come to the next point. This is note 2. Here also equation 3, that can be written in some popular way for taking the advantage in calculation. So the relation 3 can be written as alpha beta into alpha beta, and that is gamma delta. So when you will take the product alpha beta, so in that case we will take the other two sum. So that means you will write here gamma plus delta, here alpha gamma delta, you will take here alpha plus beta. So that will be minus d by a. Just you see here this one, that we can write here in that way. So now, or you can write, or so here you have to take alpha gamma, so that will be beta plus delta. You take that this summation product here, beta delta, and this product will be sum here. So that is also minus d by a. Or you can write alpha beta, alpha gamma, or you can write alpha delta. Alpha delta, so beta plus gamma, beta gamma, alpha plus delta, this is equals to minus d. So sometimes this expression helps you to solve the problem faster. So now we will come to the exercise problem and try to solve different problem which is given in exercise. So I'll start from exercise 5C. Exercise 5C इसके मापा book. Okay, so say we have taken the first problem. Say solve the equation. To solve the equation, x to the power 4 plus 2x cube plus 5x square plus 4x plus 3 equals to 0. So this is the equation of degree 4. So it has a 4 root. We need to solve all 4 roots. So how to solve? We come to the solution now. First we will write the given equation is, So here your equation is x to the power 4 plus 2x cube plus 5x square plus 4x plus 3 equals to 0. So we assume that let equation in degree 4, let alpha, beta, gamma, delta be the roots of the equation, if you considering is the 1 of the equation 1. And with the help of the relation between roots and coefficient, what we will write? Alpha plus beta plus gamma plus delta. That will be minus 2 by 1. So this will be minus 2. Question number 2. And we can write alpha plus beta into gamma plus delta plus alpha beta gamma delta. That will be 5 by 1. So that means 5. Question number 3. Alpha beta gamma plus delta plus gamma delta alpha plus beta. It will be minus 4 by 1. So that means minus 4. And alpha beta gamma delta, this is equals to 3. So it is equation number 5. Now what is given in the question paper? In the question paper given that the product of, in the question paper it is given, just to add the full question here. Given that the product of the root, the product of the roots is 1. So according to the given information, we assume that alpha beta equals to 1. 2 of the roots, product of the 2 of roots is 1. So we assume this one. This is equation number 6. You can take alpha gamma, you can take beta gamma, or you can take gamma delta, no problem. So now from equation 5 and equation 6, so therefore from 5 and 6, what we will write? We will write gamma delta equals to 3. And therefore by 2, sorry, by 3, what we have? We have alpha plus beta into gamma plus delta. So alpha beta is 1, this is 3, so that will be 1. So this is equation number 7. Now the equation with roots alpha beta and gamma plus delta. So we have seen alpha plus beta plus gamma plus delta equals to minus 2. And alpha plus beta into gamma plus delta equals to 1. So we can say alpha plus beta and gamma plus delta are the roots of the equation, are the roots of the equation t square minus the sum of the two roots, so minus 2t plus the product 1 equals to 0. So that means t plus 1 whole square equals to 0. So t equals to minus 1 and minus 1. So now we'll take alpha plus beta equals to 1. So therefore alpha plus beta equals to minus 1 and gamma plus delta is also minus 1. Now again, since alpha plus beta equals to minus 1 and the product of alpha beta equals to 1, So alpha beta are the roots of the equation p square plus p plus 1 equals to 0. And from that equation you can solve minus 1 plus minus root 3 I by 2. Again, since gamma plus delta equals to minus 1 and gamma delta equals to 3, so gamma and delta are the roots of the equation ms square plus m plus 3 equals to 0. So m equals to minus 1 plus minus root 11 I by 2. So therefore the roots are minus 1 plus root 3 I by 2, minus 1 minus root 3 I by 2, minus 1 plus root 11 I by 2, minus 1 minus root 11 I by 2. So these are the roots. So in that way you can solve the problem with the help of